Hi guys, welcome to week 12 of operating system course. This lecture is going to be very short. Um, I haven't heard back from you guys regarding any topics that you thought I should revise, so I guess things are clear, so I'm not going to go into a lot of detail of the topics. What I'm going to do today is two things. First thing is I'm going to tell you which topics you should study, because I don't want you to study everything in the course and then get confused about what's going to come in the final exam. So I'm going to tell you the topics, or at least the weeks that you should study, and I'm going to ask you questions from those weeks only. I'm not going to go through the whole course and ask you stuff from there. So that's the first thing I'm going to do. The second thing is I'm going to solve a final exam for you, which will be on Blackboard, and that would give you some idea of what you should expect from the final exam, what kind of questions will be there. So these two things, and we are going to have presentations on Wednesday. So I hope you guys are getting ready for that presentation. A lot of students have already approached me regarding, almost all of you have approached me regarding the requirements and the confusions you have regarding the project, and I hope things are clear now, because this is what I hear from you after we have discussed everything. So I think your projects are going good. You guys are doing great with your projects. Make sure everybody contributes in your project. If there are three people, all three of you should contribute equally, because if somebody says during the project presentations that I have only a small portion of the project that I had to work on because the project was not too big and so on, that would not be acceptable, because then you need to ask your group members to give you some more stuff to contribute on. So, and as I said during the presentations, I'm going to ask you questions only from the contributions you have made to the project. I'm not going to ask you the stuff other people have done. So make sure you know what you have done. Make sure you know which project you are working, of course. So you need to know exactly what the project does, and I'm going to ask you questions from your contribution, and obviously there can be some generic questions which I can ask you. For example, if somebody is using threads, and I can ask what a thread is, for example, what are different types of threads, and so on. So some generic questions I might ask, which will be definitely related to your project. So make sure you understand your part, you understand your project very well. So that's this thing, and we are left with assignment number 3. The deadline for assignment number 3 is, I think, 4th of December. So by that time you'll be done with your projects, and even if you spend an hour or two on that project, this assignment, you should be able to finish that, because I've already almost solved this assignment for you in one of the videos. So if you haven't seen that video, go to that video and have a look at that video, but try not to miss the deadline, because I have to upload your marks before you enter your final week, on final exams week. So please do not miss that. If you have any questions regarding anything, please contact me. I will still have my office hours maybe next week as well. This week we are going to have our presentation, so I might not have office hours, but next week I'm planning to have office hours, at least for an hour or so that you guys can see me if you have any questions before the final exam. So this is this thing, and we have already gone through these assessments many times. Just do good in your final exam. We are almost there. I hope you guys are doing good in the project as well, and don't miss the assignment number 3. So this is this. Let me quickly go through the important topics, or at least the weeks that you should study. um, let me be very specific. So you have to study these. No need to go through week number 1, week number 2, although week number 2 looks a little bit important, because even week number 1, I mean, kernel mode and user mode, so those things are important, but again, not to burden you too much. So I would expect you guys to study these, at least these. I'm gonna ask questions from these weeks. You should know what processes are, you should know what threads are, what is process synchronization, CPU scheduling, there are some algorithms, deadlocks, again, very important concept. Then two lectures of memory management. So I'm expecting you to study from week 3, 4, 5, 6, 7, 8 and 9. So these are the weeks that I'm going to ask questions from. So all of your questions are going to come from these weeks. So please go through them. And I have been asked this question a lot of times, students asking me if slides are enough for final exam preparation. Again, it totally depends. There is no straightforward answer to that. It totally depends. If you know the concepts, if you know the details behind those concepts, for example, for processes, I might have written only one or two things in what a process is, what is a process control block, and so on. If you know all these things and you want to revise through slides, it's absolutely fine. But you should know about all the things I have been talking throughout all these weeks. So if you know, you might have seen that during our lectures, I have been talking a lot on one slide. So all that information is available in your book, but maybe not available on your slides. So I have been talking a lot. So if you know what I have been talking about, if you know what those concepts are very well, maybe slides would help you in revising those concepts. What I would highly suggest to go through your textbook about these important concepts if possible, and go through maybe some of the questions at the end of the book to practice yourself, because if you know, if you can solve the questions at the end of your book, you are well prepared, because I'm gonna ask you questions something very similar to what we have in our book. So if you can answer the questions at the end of each chapter in your book, then you should be well prepared. So please do that, and make sure you know the algorithms. I'm gonna ask you questions about the algorithms. I'm gonna show you in a while the exam, and it's a sample exam, of course. It's not gonna be exactly what you will see in your exam, but something similar. At least it will give you some idea. So make sure you understand these concepts, the ones I have highlighted over here. Make sure you don't miss any of the details in there, because it's going to be mix of multiple choice questions and short questions. That's why you have to be very careful when you're studying. And yeah, that's pretty much it for your exam hint, or the most important topics that you should study. So these are the few of them. If you have any questions before final exam out of any of these, please contact me. You can drop me an email. Maybe if you want to have a session with me, I don't mind that as well, so I can revise you a couple of these topics depending upon the time we can have, because these last 2 weeks are very, very busy for everybody, or for faculty members also, for students also. So hopefully we can find some time for that. So that's for this. I think I need to jump to my Blackboard now. So I've created a sample exam for you guys, not for you guys, it's for me, just to show you how exam looks like. I'm going to put a lot of details over here, but for the sample exam I did not put a lot of details. So in instructions you have to be very, very careful. Please read all the instructions. So I'm going to put instructions for you over here. These are just sample instructions. And these are the instructions coming from Blackboard. So you are going to have an exam of 100 minutes, 1 hour and 40 minutes. So you have to complete your exam in 1 hour and 40 minutes. As I said that for this exam you are going to get 24 hours. You can join that exam in those 24 hours anytime you want, but you have to complete your exam in one sitting. So this is what is mentioned over here. Once started, this test must be submitted in one sitting. Do not leave this test before save and submit. So you have to complete your exam in one sitting. You cannot just pause your exam, go and do some stuff and come back and do it again, because time will be running. You have 100 minutes only, and you have to solve your exam within those 100 minutes. And honestly, trust me, I mean, with those 100 minutes, don't take them for granted, because 100 minutes might not be enough for doing a lot of research while you are solving your exam. That's how open book exams are, right? You are free to go to Google, you are free to keep your book with you, you are free to keep your notes with you while you have exams. But trust me, don't spend too much time on searching here and there. I would highly suggest you guys to prepare before final exam. You cannot just trust on your exam notes, or maybe on Google, that I will just go and copy paste the whole question over there and the answer will come out. It's not gonna work like that. Trust me, it's gonna waste a lot of your time. So don't do that, because I've tried to copy paste few of the questions already in Google, and Google was wasting a lot of time. So I made sure that Google is not helping. So don't waste your time over there. And I have made sure that you do this exam in 24 hours. So you have liberty of whole 24 hours I think it's on 14th if I'm not wrong. So you have that whole day for your exam, and all the time is in PST, by the way, Pacific time, so make sure you don't miss that. Because again there will be a long procedure, I guess, for taking a final exam again, so don't miss your final exam. I mean, if I am a student, I would not even think of missing a final exam. So make sure you guys be on time, try to solve it with full preparation, and hopefully you guys can do good, right? So read these instructions properly before the exam. I'm going to put a lot of instructions over here to make sure you guys know exactly what, of course, I mean, you will know what exam is going to look like because I'm going to solve one for you, but read these instructions very, very carefully. All right, and yeah, so let me begin. So you're gonna see something like this. Again, the instructions are here for you. So questions will be like this. As I said, your questions will be a mix of multiple choice questions and short questions. So you will find an exam like this. Well, this exam is a sample exam, but I've brought here for you some real questions. So you should expect questions like this in your final exam, or maybe some easier questions, or maybe some harder questions than these, but at least you will find questions like this. I mean, these are real exam questions. Of course, I will make sure that these questions don't appear for you in the final exam because these are sample questions, and I'm going to solve it for you so you know the answer. So I don't want to bring these same questions in the final exam, but they'll be at somewhat same level of difficulty. All right. So since it's 100 minutes exam, you will have enough time to solve this. I mean, I have made sure that you guys can at least revise as well your questions after solving this. I'm assuming again that you are not spending too much time on Google or on books here and there. You are depending a lot upon your knowledge of this course, which would definitely help you solve this exam much faster than if you spend too much time in books and here and there. So there are 20 multiple choice questions. So there are going to be 20 multiple choice questions. I'm assuming true false as multiple choice as well. So there are going to be 20 of them, and each one carries 1 mark. All right. So each of these multiple choice questions, they carry 1 mark. All right. So you have 20 of them, 20 marks for MCQs. Then we have essay questions or short questions. I'll call them essay questions technically, because I have created essay questions on Blackboard, because with short questions you do not have enough space for short questions over here. So I've created essay questions here. Each essay question is 5 marks, and you have 4 of them, so 20 marks in total. You have 20 marks of essay questions, so total marks for your final exam are 40 marks, 20 marks for your MCQs, and 20 marks for your short questions or your essay questions. All right, there are 4 essay questions, 5 marks each. There are 20 MCQs, 1 mark each, and they have 40 marks in total. So this is how it is. Let me quickly solve it, and obviously these questions are going to come from the pool of questions. I have created a lot of questions already, I think 40 or 50 if I'm not wrong, at least MCQs, and I have randomized them. Hopefully you 2 students will not be getting same questions, so I'm trying that. Let's see how it turns out. So yeah, so this is the overall exams guideline. This is how it's going to look like, and let's quickly solve them now, right? Okay, so question number 1 is, in modern operating systems, one of the core functionalities is to keep CPU utilization at maximum. In order to maximize CPU usage, which of the following should be true? So there are 4 options, you have to choose one of them. So it says that in order to make CPU utilization maximum, which of these statements you think it's true? All right. So first one is, fewer processes should be given to CPU. If we give fewer processes to CPU will not have maximum utilization. So this is false for sure. More and more processes should be given to the CPU for processing. This looks true to me. Obviously, if we give more processes to CPU, it will have more utilization. Process scheduling should make processes wait for long. So if process scheduling is making a lot of processes wait, then it's not gonna make CPU utilize to its maximum. all IO interrupts should be blocked. So if we block all the IO interrupts, it's always not a good idea, of course, which is not going to make CPU utilization. It is somehow going to make CPU utilize more, but then you won't be able to do IO interrupts, which CPU needs sometimes. So I guess this option makes a lot of sense. Okay, next one. Chances of deadlock occurring in operating system are high if only one process can use a resource at a time. So with deadlocks, what we do normally is we say that so for deadlocks we have some conditions, right? If you remember, mutual exclusion, right, and so on. So we say that the chances of deadlock occurring in operating system are high, which means that there are more chances for deadlock to occur if only one process can use a resource at a time. So if one process is using the resource at a time, then obviously it's going to make deadlock occur, right? Because this is going to increase the chances of the deadlock. So we're going to make it true. Processes have different states. We know that. So they have different states. To make sure all the processes get a fair chance of getting a CPU, if a process is in ready state, it is expected to be, so out of all the states, if a process is in ready state, what it is expected to do? If it's in ready state, waiting for the processor to be assigned, yes, right? So if it's not in running state, it's in ready state, which means that processor is waiting to be assigned to a processor, right? Or a processor should be assigned to this process. That's why this process is waiting. So I guess this one is true, but let's read the other one. Ready to take an IO device? No. Otherwise, if it's ready to take a device, then maybe it's in blocked state. Ready for an IO interrupt? No. Ready to get terminated? No. So this one, yeah. Okay. Processes have different states. Okay, so yeah, some of the questions will appear here again for me because I've made 10 questions as sample, and I just made them repeat for this sample exam. So some of the questions will appear again and again over here, but for you it will not appear. So this question number 3 and question number 4 are repeating for me because it's taking it from a very small pool of questions. So that is for the sample exam only, right? But for you guys, there will be a bigger pool of questions, so you won't have any repeated questions for you. Okay, so in round robin scheduling, a process can get a second chance of if preempted. So preemption means if a process was being worked by a processor and a high priority process came, then CPU will be taken from that process and will be given to the new process. Okay, then what to do about this process that was being taken away from the processor? In round robin, obviously it will go to the end of the queue, right? So it will get another chance. So this is what it's saying. So yes, it will get another chance. Chances of deadlock, I think we did this maybe. Can use at a resource time. Yeah, I think we did this. It's the same thing, yeah. Modern computers have multiple processors. Okay, modern computers systems have multiple processors that make them a little expensive than single processor. Okay, however, multi-processor systems overcome one of the biggest problems in single processor system. What is that problem in single processor? So what is one problem that multi-processor system overcomes that is a big problem in single processor system? So let's read the option. More processes will be processed in less amount of time. With multiprocessor system, more processes will be processed in less time, not necessarily. Operating system will be busy switching between different processors. If there is a single processor, then it will not switch. Processors have to wait for a long time to take their turn. I think this one is true because if there is a single processor, then obviously processors have to wait for the processor to get their chance, right? So they have to wait for, they might have to wait for long because there are no other processor. In multiprocessor, they don't have to wait for too long because there are multiple processors. So I think this is the right one. Fast context switching between processors will make the system complex but fast. That's definitely not true because with multiple systems it becomes fast but not necessarily it becomes complex but not necessarily it has to be fast because of so many reasons, right? We have discussed about those reasons. Consider a scenario where 3 page frames are given to a process and consider none of those pages are in the memory. So this is paging from memory management, if you remember. Assume the reference string is this. We did one example, I think something like this. How many page faults will occur if optimal page replacement algorithm is used? Well, optimal page replacement algorithm, we have to use this algorithm to see how many page faults will occur. Okay, so this is a string. If you remember, we did something like this, right? So and there are 3 pages, so we have 3 pages in the RAM, so our RAM can maximum have 3 pages, 3 page frames, and this is our string. So first time there will be no page in the RAM. This is what it was said, right? Considering there was no page in the RAM. So if there was no page in the RAM, then P1 comes, it means there is a page fault because it was not there in the RAM. So 1 page fault. P2 came, again P2 was not in the RAM, again page fault, so 2 page faults. P1 came, P1 is already there, so no page fault. P3 came, it was not there in the RAM, 3 page faults. P7 came, it was not there in the RAM, so another page fault, 4 page faults. Then we have P4, never there, another page fault, 5. Then 5 came, another page fault, 6. P6 came, another page fault. Then P3 came, I think, so this is 5 and this is 6. So just a second. So 1, 2, 3, 4, 5, 6 and 7. So there are 7 page faults because of what we have here, and you have to choose from here, right? So we did this in our page replacement algorithms, if you remember, when we were studying my memory management. Then we have round robin. Yes, I think we did this. And in order for the system to have better performance, following should be true. Process management should be efficient for sure. If a system needs to perform better, process management should be efficient. All IO devices should be turned on, not necessarily. If printer is not turned on, it's just fine. System will not have any impact on that. It will just show user that printer is not on, for example. System should have no resources attached to it, not necessarily. It has nothing to do with our system's better performance. Majority of process should always be in the waiting state, not necessarily. It has no impact. So I think this one is the one we have. One of the important parts of PCB for process is a program counter. Yeah, we have in PCB we have a program counter. It is one of the most important responsibilities it has one of the most important responsibilities for PCB. All right, program counter has some responsibility. Yeah, the responsibilities of program counter in PCB is to tell about the next executable instruction. Of course, this is one of the responsibilities of program counter. It is going to tell which next instruction should be executed. To hold the content of the process, no. To hold the process state, no. None of our, no. This is this one. All right. So this is this. Question number 12. Mostly threads make system efficient. Yes, but not necessarily. And hence processes are divided into threads. Yes. However, threads can take some time to terminate. Yeah. Which of the following statements are true regarding threads? Threads take more time. Oops. Should be somewhere down. This is an option. Okay. So threads take more time to terminate than processes? No. If you remember, there was this comparison between threads and processes. I think this was one of the points. So normally threads don't take more time than processes. Threads take less time to terminate than process. Yes, that is true. There are more chances of halting the system when threads are being used. Not necessarily. I mean, it's in fact opposite. If one of the thread is blocked, the system will not block because only one thread is blocked. The system will still run, right? None of above, no. So I think this one, threads take less time than processes. Okay. Modern computers have I think we did this. I think it was processes have to wait for long for their turn for processing. Yeah. Mostly threads make, I think this, right? Threads take less time. Yeah. And I think we did this as well. One of the PCB, I think we did this. Operating system use, okay, this we haven't done. Operating systems use both short-term and long-term scheduling. We know that. Which of the following statements are true about long-term scheduling? Okay, long-term scheduling, all right, are invoked frequently. That is not true. So short-term scheduling is invoked frequently. Long-term scheduling are invoked infrequently. That is true. They are not very frequent when they are invoked. Cannot control degree of they actually help in controlling the degree of multiprogramming. Does context switching at a rapid pace? It has no, they don't. Not necessarily. They can, but not necessarily. So they are invoked infrequently is the answer. So because that's why they are called long-term scheduler, because they are not invoked frequently. They are invoked infrequently. Okay. In order for the system to have better performance, I think we did this. Operating system use both short-term. I think we did this. In operating system, one of the core functionalities of CPU, I think we did this as well. Process should not wait. Which one is this? Operating system is to keep CPU utilization and maximum. In order to keep maximum utilization, okay, more and more process should be given to the process. So yeah, so this is for our 20 questions in MCQ section. It's not a section, I mean it's just one part of the final exam. So the other one is this question. Okay, let's see what it says. This is a short question. So I won't say it a short question, I will say it an essay question, because it not necessarily has to be short. 5 points when you are trying to explain the question. I mean, you are trying to answer a question. It might take a lot of space. It might take a lot of sentences, right? So I will not call it a short sentence because it's 5 marks. It's not 1 mark, right? So you might have to give multiple examples. You might have to give different justifications of why you have chosen this answer and so on. So you might have to take a lot of space, write a lot of sentences to explain your answer. So that's why I'm not going to call it a short answer. It is an essay question. All right, let's see. As a system developer, one of your responsibilities is to develop an algorithm that can schedule the processes for the CPU to process. To perform this task, you should be aware of criteria behind optimizing the scheduling algorithms. What do you think are the main? In fact, let me quickly show this to you. So I think we did this in process synchronization. Yeah, I think we did this somewhere here. Not here. Let me quickly show the other one. Yeah, CPU scheduling, let's see it. Yeah, so I think these are the criteria, right? So these are the criteria which you should choose as a system developer to make sure the algorithms are optimized properly. So it's CPU utilization, it's throughput, it's turnaround time, waiting time, and response time. And if you remember, we did an exercise on that as well. We developed a program where we found the waiting time and response time as well. So maybe you have to explain these, what they are, with example, each of them with example. If you go to my video lecture where I recorded this, I gave you an example for each one of them, or you have an example as in the form of a program as well. I gave you that program. We wrote that program, and where we found out the turnaround time, waiting time, and response time as well. So I think this question is related to that. Yeah. So you can write about that, give justification with example for each one of them, and yeah, this question is about that. No, I'm not going to type it over here. That's why I wanted to just show you the answer of this question. So this kind of answers this question. So these two slides, this one and this one, they talk about that, and you have to obviously explain and justify your answer. So yeah, so I think you got the idea. So that's how you have to do it. You have to first explain what they are, then why they are important. It's written, and you can just refer to my video as well. So it will take me a lot of time to write it over here, so I'm not going to go into a lot of detail again, because that's already available for you in the video, so you can go through that. Okay, so the next one is, what is first come first serve algorithm? I think I just opened this. Yeah, first come first serve. So there is a scheduling algorithm. So you have to tell what that is. Some details are available over here, so you can use that. Explain with examples. So you can give an example. This is one of the examples. Then what would be the order of processing of these processes? What would be the order of processing of the following processes using first come first serve, assuming the processes belong to real-time system that tackles flight scheduling on airport. So these are some of the processes, and you have to tell if first come first serve algorithm is used in real-time systems, that is, for example, a real-time system for file scheduling, how these processes will be executed then. So process 1 comes, it has the burst time of 8 milliseconds, for example, priority low, then we have this, then this, then this, for example the priority is unknown. In first come first serve, it doesn't matter what their priority is, it doesn't matter what their burst time is, whoever is coming first will be processed first. So P1, P2, P3, P4 and P5, this will be the sequence of their execution. It doesn't matter even if they are in real-time system. Even in real-time system, it matters a lot their order, right? So P1, they will be programmed in such a way that some P1 is done first, P2 is done second, third. For example, if you are in a car manufacturing system and first process is going to put a body of the car on the roller, which is going to just go to the next process, then next process is going to maybe put some doors to the car. If there is no body, then doors will not be placed over there, right? So even in real-time system, the first come first serve will be scheduled in such a way that they make sense, right? So you have to explain this here and so on, right? Okay, next we have is real-time systems are quite useful these days, especially in manufacturing industry. In real-time system, scheduling is an important task that can help in automating the whole process. What are your thoughts on real? In fact, I answered few of them here, and I gave you an example of manufacturing system as well, so you can tell that these are real-time system where their sequence matters a lot, and processing matters a lot. And you have to give example. I gave you manufacturing example. What are some major differences between scheduling a real-time system and traditional system? So I told you, for example, we take an example of pacemaker. Pacemaker is another real-time system, a tiny one. It becomes very critical for pacemaker to do a click at regular intervals of time. If it doesn't do that, then it can be a disaster. A person can lose his life, right? If pacemaker should not skip a heartbeat, right? If it skips a heartbeat, then it becomes really critical, right? However, in traditional system, for example, I gave you an example of your assignments. For example, if you miss your assignment, I still open the assignments for you, right? So not that critical. So these are some of the examples of real time and traditional systems. I gave you an example as well, and I think there was I don't remember where it was. Yeah, it's here. Wow, it's in one course. I mean, 1 week I have all the questions for you. All right, okay, so these are real time systems and a lot of details about these systems and so on, right? So you can get that information from there. So this is what you have to write here. Then we have so we have questions like this. So I try to give you flavors of different questions, so you should expect any type of these questions. So for example, over here, this question is more about your thoughts about a system, right? This is more about that. This is more about an algorithm. So we have talked about different algorithms. It's talking about algorithm over here. Third one is more about comparison of systems, so real-time system and traditional system. And fourth one is more about I mean, it's kind of, again, it's an algorithm, but it involves some analysis. So there are some open questions that have right and wrong answers. So over here it has a right and wrong answer. This has a right and wrong answer, but over here it doesn't have a right and wrong answer, but it depends upon how you see that. But obviously, I mean, your answer should not go beyond the spectrum of that question. It should still remain within the boundaries of the right answer. So yeah, so I try to give you a lot of flavor of the questions over here. MCQs, I mean, all MCQs, they look similar. Just wanted to give you a flavor of how hard they can be, how easy they can be. So yeah, so over here what we have is, in the following diagram for a single processor system, consider at least one process always. So these are different process states. So this is our ready state, this is start state, create state we normally call it. Then we have a ready state, we have running state, terminated, and block state, right? So it says that consider that there is always one ready process, which means that CPU has maximum utilization. So there should be always at least one ready process over here. So which means that even if something is running, it has something in the queue. So consider the following scenarios. If one process terminates, the other process starts immediately. So if one process terminates, then it means the other process starts immediately. Okay. A process in block state can move to ready state even if another process is running. So from block state, a process moves to the ready state even if one process is running. Okay. if it is a preemptive scheduling scenario, which means that any process can from any process CPU can be taken anytime and can be given it to the other process. It is a non-preemptive scheduling algorithm, so which means that the processor cannot be taken from one process and cannot be given to the any process cannot be given to any other process unless and until that first process is complete. Okay, in your opinion, which of the above cases would be true based on this, right? Okay, based on this one, let's see again. So we have this state. If one process terminates, the other process starts immediate. Not necessarily. If one process terminates, not necessarily another process has to start. Not necessarily. Maybe there are no other processes to start. So first one is definitely not true. So there is no condition that if one process terminates, another process should start. There is no condition like that. Maybe there are no other processes to start, right? So not necessarily. A process in block state can move to ready state even if another process is running. So there is a process in block state, it moves to ready state, but one process is already running, which is absolutely fine. So if process is running over here and another process wants to move from block state to ready state, is absolutely fine. From block state it cannot move to the running state, obviously, but from block state it can move to ready state if another process is running. So this is true for sure. It is a preemptive scheduling scenario. It's a preemptive scheduling scenario, which it is. It's very clear from here that processes are moving from block state to ready state. They are moving from ready to running state. So they are always moving. So if if one process is running in the running state and that process needs IO device, it will be moved to block state. So processor will be taken from that process and that process will move to block state, right? So it means that we are taking processors from the processes and moving them or kicking them to another state, right? So which is true. So it means that it is a preemptive scheduling. That is true. It is not a preemptive scheduling, which is false, because it is a preemptive scheduling. So if it's a preemptive scheduling, it definitely is not preemptive scheduling. So in this case we have two cases which are true. So you just have to maybe write over here B and C are true, right? And you have to give justifications, by the way, also. So you need to tell why B is true. So you'll say over here B is true, and then you provide your explanation why it is true, and I just gave you the explanation. Then you write C is true, and then you will say why C is true, and you have to tell, of course, why A and D are not true as well. So you have to start with A, why it's not true, B, why it's true, C, why it's true, D, why it's not true. So you have to write all of them, right? So you have to write all of them. So that's pretty much it. This is how you should expect the final exam to be. I have done it pretty quickly for you, but obviously it will take you some time to do that. And make sure that you do and read that very carefully. Read the instructions properly. Don't make sure that you are doing it in such a way that you are not losing marks. This is the last thing I want, right? Don't lose marks, guys. So for some of the marks you might for some of the questions, at least for the MCQs, you will get your marks over here. So it will tell you which one are correct, which one are wrong. So over here I missed one of them. All right, I don't know, maybe that appeared a couple of times, that's why I just anyway. So it's one of them is wrong, and you will get your answers over here. So you can get your answers for MCQs over here, but for short questions it definitely needs grading. So I have to grade them for you, and then you'll be able to get your marks. So I think you cannot go back to review your questions. So before you submit your questions, you should make sure that you know what you are doing. All right. So once you have submitted your exam, you won't be able to go back and change your answers. All right. So please submit only when you are done. All right. Having said that, if you do not complete in 100 minutes, the system will automatically save your answers and submit. So don't be late. All right, don't be late. So make sure that you submit your answers on time, because if you don't submit your answers, if 100 minutes are elapsed, then system will automatically submit your exam, which means that your answers have been submitted. All right, so make sure you keep an eye on the clock as well. I think clock was running somewhere, I haven't seen that, but just make sure that it is running, and I think it will tell you that you have 5 minutes left, 10 minutes left. I think it tells you Yeah, it says somewhere, it will tell you, I think so. But you should keep an eye, all right? You should definitely keep an eye on the clock. And anybody who does not appear for this final exam won't be able to take this exam after the deadline. I mean, this is just a sample exam. I put this deadline, but for you, it's not this one. So within those 24 hours, if you don't appear, then unfortunately you won't be able to take this exam. All right. So please do not miss this exam. Uh, Appear for this exam, solve it. If you have any questions, please do let me know. If you are confused about any concept, you think you are still not um, still not very clear about that concept, please let me know, and maybe I can revise that quickly, although we are very short on time and everybody is very busy. You guys are very busy, I know, with a lot of projects. So yeah, that's pretty much it for today's video. I think I don't have anything else to cover. I just wish you all the very best. And yeah, for this exam, I think it makes sense to you, because questions will be somewhat similar to this. Obviously, uh, the level of difficulty will be similar. You might have seen questions already, but obviously they will not be the same questions. Some of the question might be a little bit more longer, I don't know, but they will be at the same level. So I hope you guys understood this. I hope you guys now know what kind of exam you should expect, because a lot of people were asking me about this, and we have to live with this. Unfortunately, this is how exams are going to be this semester and maybe next semester as well. um, we have to live with it. Hopefully you guys do good in this. Hopefully you guys perform well. I wish you all the very best for this course. I enjoyed this course a lot with you guys, although there was very less interaction with you guys. Some of the students did appear in my office hours and other sessions also. So it was good to see you guys, good to meet you guys. Keep in touch, guys. Hopefully I'll see you maybe in next semester with some of the courses. If not, maybe in future. If you have any questions, do let me know. Wish you all the very best. Do good, and I'll see you during your presentations. Have a nice day. Bye bye.